Hello Adolphus, let me introduce you to this project and this design, what you can see right in front of you. We've been asked to design temperature measurement system capable of measuring the temperature between 0 degrees to 100 degrees by using RTD resistor temperature detector, or in our case variable resistor, and also a bridge had to be designed to achieve the output between 0 millivolts to 100 millivolts. Additional components, operational amplifier also had to be chosen to amplify the output needed for converter and other components such as LCD or diodes. So let me tell you what we have. By using this multisim program, we could design the system, but we could also simulate the system. As you can see, this little play, that's where we can run our system to see if our outputs are as expected. So let me walk you through each component. On the left hand side, we have power supply, 10 volts VS. We have our circuit bridge, which you can see right here with 4 resistors. This is our RTD resistor at the moment, and 100 ohms representing 0 volts. And our other 3 resistors, what has been calculated. At this particular stage, this bridge is at equilibrium. From our null method, we know that if this part of the bridge is equal with resistance to this part of the bridge, literally we should have equilibrium, and we should achieve, in this case, 0 millivolts on our output from the bridge, which we will check very shortly. We have here also our circuit for operational amplifier. This is inverted amplifier, as you can see, judging on the wirings. We've got 2 resistors, and from the value of those resistors you can tell we've got the 100 gain, what is actually needed to achieve 10 volts right here at max. We have our input voltage to our OP amplifier. And also we've got 2 multimeters positioned, first one right here, so we can see the output from our bridge, voltage output, and also another one at the end of our operational inverter amplifiers. So let's run a little simulation. If we're going to press play here, you can see right here, we can see the voltage, output voltage from our bridge, which is very close to 0, and that's exactly what we've been expecting. And we can see 266 millivolts, which is slightly more than 0 volts, but this discrepancy, this high voltage here, could be related to the formulas what we've been using, which, for example, calendar Van Dusen formula would help us to do a bit more precise calculation, because it takes under consideration characteristic of the materials what RTD is made of. It could be related to dissipation of each components, but also stuff like 10% or 5% of tolerance in our resistance, representing a silver or gold band. And finally, this little error could be created by calculation and rounding in our calculation, what probably has been made a bit too early. Coming back to our operational amplifier, this LM124AD has been chosen for the tab right here. And it got quite few advantages over others. Is temperature range is from -55 degrees to +125 degrees. It has large voltage gain. Load input voltage is also something we've been looking for. So let's make some changes in our resistance to see if we can achieve a correct voltage when we're going to change this RTD from 100 ohms, what representing 0 degrees, to, for example, 139.4 ohms, what representing 100 degrees. So if we stop our simulation right here, if we double click on our resistor here and change that from 100 to 139.4, what we know from our calculation in our chapter 3, and if we're going to try to run it, we will see what output we will achieve in each component. So play. What we can see, our goal was to achieve approximately 10 millivolts on our circuit output bridge from quarter-wave bridge when temperature raised to 100 degrees, and that's exactly pretty much what we have here. Still not perfect, but we already mentioned that previously, but 97.8 is quite close figure we've been looking for. Let's see what's happening after our OP, operational amplifier. Again, we've been expecting to have 10 volts, and achieving 9.5 is very close to what I was expecting. Thank you so much for your time, and I will see you soon on our next session.